Roger T. Kilgore, Principal of Kilgore Consulting and Management. Mr. Kilgore is a professional engineer and is board certified in water resource engineering. He is based in Denver, Colorado, and has over 30 years of experience in hydrology and hydraulics, stormwater management, water quality, and flood mitigation. He has written several design manuals for the Federal Highway Administration, including HEC 17, Highways in the River Environment, and HDS 2, Highway Hydrology. He has also served as a principal investigator of NCHRP 1561, applying climate change information to hydrologic and hydraulic design of transportation infrastructure, and NCHRP 2560, Watershed approach to mitigating hydraulic impacts of transportation projects. Welcome, Roger. Let's get you going here, Roger. One of these two.
Yeah, looks like that one.
This one. There you go, sir.
Great. Yep.
Perfect.
And good afternoon, everyone. This presentation is about that latter NCHRP project, a watershed approach to stormwater management requirements, basically. And what it's about is encouraging people to think differently about stormwater management and meeting stormwater management requirements when developing transportation projects. Here is the project team that I was privileged to work with. We each had our various roles, but it was a very good team to work with, an interdisciplinary team, including economists and environmental estimators, I guess you would call them. So it was a good group of people to work with and talk about these various problems together. The objective is listed here. Basically, the project was to develop guidance for state DOTs, although it could be for municipal DOTs as well, for developing and implementing watershed-based strategies and techniques for mitigating hydrologic impacts about transportation facilities. So we already do this, and this is asking us to think more broadly about how we meet stormwater management requirements when we introduce impervious areas in our transportation projects throughout a watershed. What this is not about is making your life more difficult. It's not about making your life more complicated and requiring you to do things that you don't want to do, but it's about expanding your tool chest. We've heard a lot about resilience this week. We've heard a lot about sustainability, and we've heard about nature-based solutions. And thinking about meeting stormwater management requirements on a watershed basis really allows us to do all of those things: sustainability, resilience, implementing nature-based solutions on a watershed basis. So you'll see how that works with the watershed basis as I go through it. The mitigation techniques did not exclude our traditional detention ponds and retention ponds and on-site type things, but the things that we focused on are listed up here. And so here's where we're trying to use natural systems more to meet our stormwater management requirements. So we have wetlands that we're talking about, uplands, redevelopment of those areas away from wetlands, forestry, stream restoration, and the different types and focuses of stream restoration are listed there in terms of bed and bank stabilization, riparian buffers, in-stream and floodplain enhancement. All of those are different aspects of what you can do with stream restoration. And then we also looked at agricultural practices and changing agricultural practices to improve stormwater management. So those are the types of what we call landscape mitigation measures that were part of this process. We also looked at different kinds of stormwater management or hydrologic metrics as well, and those are listed up here. The bottom one is the one we ended up developing a tool for, but all of these can be met as we expand the types of questions that we as hydrologic engineers and hydraulic engineers want to answer, ranging from environmental and low flows, 7Q10, that sort of thing, to the water quality storm, which people talk about a lot, the first half inch or the first 3/4 of an inch. We can focus on monthly flows related to wetland restoration. We can focus on channel forming flows and the various ways that channel forming flows are defined. And then, of course, the traditional flood peaks, the 2, the 10, the 50, whatever, in terms of the peak value, but also the volumes and looking at those. So these were the kinds of metrics that we were looking at applying a watershed approach to. Oops, wrong direction. One dimension, an important dimension of this, is to think about the co-benefits of what we do. There aren't that many co-benefits with on-site stormwater management treatment. And so in many ways, we're selling ourselves short in looking at some of the solutions that we're looking at. This is a list, and we'll talk more about how we evaluate them, of things that these landscape mitigation measures that I just introduced can offer to us. It can help us manage our adaptation to climate. It can help us improve water supply. It can help us do all of these things on this particular list, all the way through recreational opportunities. That's not something that DOTs get involved with traditionally, but with partners, those are things that can be benefits that can attract people to our projects. We're always looking for allies in developing our transportation solutions, and so these co-benefits, by recognizing them, gives us an opportunity to find more allies in moving forward with our various projects. Now, this is a scary kind of flow chart, but we developed an overall framework. How does a DOT think about the watershed approach, looking at a watershed approach to meeting stormwater management requirements? And I'm not going to go through all of this, but I'm going to focus on 3 main components of this particular flow chart. Up on the upper left, I'm going to focus on objectives. Obviously, we need to know what we want to be doing as a DOT, why we are looking at this, and that may be just to meet our stormwater management requirements. We also want to try to identify objectives, or try to identify stakeholders who may have different objectives that can be complementary to our objectives. And then, after talking about objectives, I'm going to then go into a screening level of analysis. People have used the term actionable, screening level of analysis that will evaluate the effectiveness both from a stormwater management point of view, but also from a co-benefits point of view of what these various landscape measures can do for us. And then if we can't get to an actionable point in a screening, then there's the detailed analysis, which is where the watershed modeling comes in, which is why I'm in this session. So those are the 3 components of this work, of this framework that I'll be talking about. And I'm going to talk about it in the context of a case study. This is a case study in Colorado, a creek called Piney Creek. It's not Clear Creek. I hope you're not disappointed. But this is Piney Creek, but there are probably Piney Creeks all over the country as well. Where the little blue indicator is, that's the watershed outlet. So this predominantly flows from south to north in terms of getting yourself oriented. And in terms of our objectives, in this particular case, and this is a hypothetical example, it's a real watershed, but a hypothetical example. Our DOT objectives are to expand the roadway network because this is a developing area and a lot more people living there and working there, and so the roads are inadequate. And the DOT also is interested in satisfying both peak and volume requirements. Now, you don't have to have stakeholders participating with you in the project, but it certainly helps in terms of taking advantage of those co-benefits. But in this particular case, there are a lot of groups. Some of them are regulatory agencies, state agencies, but others are groups that are interested in wetland restoration, they're interested in reforestation, and some of the objectives of those groups in this particular case were to improve aquatic habitat in the stream, as well as terrestrial habitat. And then where possible, there are many groups in this watershed that are looking for enhanced recreational opportunities. So those are some of the things that could be attractive to partners in this particular example. And then the highest and best likely candidates for the landscape mitigation measures included 2, stream restoration and uplands restoration. Now, on-site mitigation is still a possibility. I don't mean to imply that we're not talking about on-site as part of the solution, but the example here is focusing on the off-site watershed-based solutions. So here's the same watershed that is now overlaid on a land use map, and you can see that much of the watershed is already developing and more of it is continuing to be developed. A couple of things I want to point out to orient you in terms of the later discussion that I have is, first of all, the concept of assessment points. These are the points within the watershed where we're going to be evaluating the stormwater management performance and the accrual of co-benefits. So here I have two up in the outlet. I'll call that my downstream assessment point. And then I have another one about in the middle of the watershed that is downstream of most of the highway activity. And you can see the highway activity are these gray lines, and the estimated total project impact is to introduce 136 impervious acres that weren't there before. So pretty large effort, but an important point is this could be conceived of with a watershed approach, something that could be over decades. So this is not necessarily a project that would be done in the next 2 years, but it's some in the next 2 years, some in the next 5 years, some in 10 years, some in 20 years. And with a watershed-based approach, you can look at that larger time scale in terms of your mitigation. And then the two mitigation measures that we'll be looking at are stream restoration in the upper part of the watershed. There's more degradation up there, and the potential for stream restoration exists more in that area. And then uplands restoration in the lower part of the watershed. So you can already see that there requires some flexibility in thinking about what compliance means. And that requires flexibility not only on the proponents of the project, but also on the regulators. And that could be a big barrier because we're talking about restoration of upland areas downstream of the project. And so that has its own challenges. So here we've got the project, and we've got the objectives for both the DOT and for the stakeholders. And now I'm going to talk about the screening analysis. And one of the, I think, accomplishments of the project team was to come up with some fairly easy screening tools for the hydrologic analysis. And this is an example of one of the tabular outputs that we came up with, where through modeling several sites across the country using some HSPF modeling and different project impacts, different landscape mitigation measures, we came up with a series of tables that told us for each acre of impervious area, how much forest restoration do you need to get you back to where you were in terms of peak flows and in terms of peak volumes, or in terms of volumes. And we did that for forest restoration, the uplands, and the wetlands restoration. And you can see for uplands, for example, for the 100-year peak flow, for every acre of impact, you need 2 acres of forest restoration to compensate for the 100-year. 1.3 acres for the 2-year peak, and going across here, 10.3 acres if you're trying to get the 100-year volume back to where it was, and that's a lot. 1.5 if it's the 2-year volume. Now you see some NAs in there too, and what we tried to do with all of these watersheds that we analyzed is to create these envelopes so that we could, where we were looking for consistent patterns. Where you see NA is where we failed. We didn't find a pattern that was really, that we could really put in this table. Now, we had more than one of these tables. We had tables for where we had mitigation downstream of the project, mitigation where we had upstream of the project, and different characteristics of the sites where these restoration or where these mitigations would be taking place. And so there's about 8 tables, but this is one of the tables that I'm going to use for this particular example. We also had, before I say that, so for this particular example, you recall we have 136 acres of impact. And so here's those 4 numbers that I had circled here. So depending on what our criteria are, we have a different level of mitigation that's needed if we are going to use uplands restoration. And that's these numbers down here. So if we're just interested in the peak flow of the 2-year event, we need to mitigate 177 if all we're going to do is the uplands restoration. And of course, if we're trying to get the 100-year volume, we've got a pretty large uplands restoration project ahead of us. Now we're also looking at stream restoration in this particular case, and we have a similar table, but instead of acre per acre of mitigation, we came up with ratios, again through these models across the country and different kinds of sites, stream length that needed to be restored versus per acre. So for example, it was not sensitive to the return period of the peak flow, but we needed 45 feet 45 feet of stream restoration per each acre of impact. Now, there's a lot involved with trying to represent stream restoration in watershed models. And so this is a gross simplification, but it's intended to be a screening tool. You can see more NAs with the stream restoration. But in this particular Piney Creek example, so we have those numbers that just came out of the table up on the upper part, and then just kind of ignoring the 410 because I don't want to deal with it. I focused on the 45 feet, which would mean we'd need 6,000 feet of stream restoration. And there's a big question about whether we'd have that much potential stream restoration in this small watershed. So we have to think about what's realistic too. But in terms of the screening, that would be a goal. So what we need to think about is this screening information enough? Well, first of all, you'd have to put together a plan that said, where are you going to put the uplands restoration? Where are you going to put the stream restoration? Do we get enough combined to have the desired effect on the stormwater management requirements? And have we attracted enough interest from proponents of stream restoration and uplands restoration to make a project feasible? Well, if you do get to that point, that's great. Then you don't need to do the detailed analysis. But if you don't, then you do need to do detailed analysis. But I forgot I was going to talk about the co-benefits before I got through there. I get excited talking about the stormwater management portion. I neglected the co-benefits, and what we did in terms of screening for the co-benefits was to come up with these causal chains, because I, as a water resources engineer, don't know a lot about co-benefits, and a lot of people that might be trying to apply this won't. So our team set up these causal chains of what typically occurs with a particular action. This particular example is for wetland creation, and we've identified the kinds of environmental changes that often occur when you restore or create wetlands, ranging from ambient water quality improvement to carbon sequestration. And then those lead to various ecosystem services that can be valued by human beings. And that can range from improved drinking water to climate stabilization. And there's linkages between these two, so you don't have to be an ecosystem services expert to understand what the benefits of these landscape measures might be. And then we also developed screening matrices that you can put together to identify, from a checklist standpoint, what are the things that might be applicable for your project. And that could be something that you can bring to the table to help advance your project. And it can get somewhat specific in terms of the Piney Creek co-benefits for stream restoration. We identified that the stream may support recreation. There's a reservoir downstream, that's the lunchroom downstairs, the reservoir downstream that supports a lot of recreational activity, including fishing, and so improved water quality, less sediment getting down there would tend to increase those recreational benefits. Similarly, for the uplands restoration, there are a lot of residential areas, and the view sheds can be improved by having natural grasslands. And the DOT could benefit by having people develop recreational facilities like picnic areas in those areas. So you're starting to think about the project in a way that's broader that could, again, attract more allies. But as I say, if it's not enough, if you haven't gotten there in terms of an actionable plan, then you go to more detailed tools. In terms of the detailed tools for the stormwater management, then instead of using the simplified tools that we develop based on watershed modeling, you do your site-specific modeling. And so based on some initial analysis and being able to identify just 16 acres where we found in the watershed instead of the 177 that I mentioned, where we could do uplands restoration. Still 16 acres is a pretty large plot of land. And we found about 2,100 feet of stream restoration that could be beneficially applied in that upper part of the watershed. We modeled that for this particular watershed. Other scenarios can be considered and should be considered to see what the best balance of meeting your stormwater management requirements are, along with what the co-benefits are. But this is what we first tried and for this example, and we had to ask ourselves then, are the hydrologic goals met? Now just to remember what we're talking about, I'm first going to be talking about this downstream the upper assessment point is what I'm going to talk about. I'm going to work upstream to downstream. So I'm going to just evaluate the stream restoration because the uplands restoration has no effect at that middle assessment point. And here's the results of the several modeling runs using the HSPF model. The first column is the baseline values for the 4 parameters that we're looking at, the 2-year peak, the 100-year peak, the 2-year volume, and the 100-year volume. And those were the CFS values for the peak and acre feet for the volumes. Then you can see the increases in all of those values in the second column for the highway project by itself without any sort of mitigation. And then when we add the stream restoration, the 2,100 feet of stream restoration, you see they drop down, but not all the way down. So obviously it didn't fully mitigate at that particular assessment point. And then just looking at, we started out for the 2-year at 223, the project went up 252, stream restoration brought it down part way. It brought it down 21% of what we wanted to do. Now, the next column here is what percentage of the mitigation that we thought from the screening did we actually apply? Because I wanted to compare how close the screening was to what the modeling, the site-specific modeling showed. We applied 34% of the stream restoration, so our screening actually underestimated a little bit how effective stream restoration could be. Not orders of magnitude, but it did underestimate it because we got 21% benefit just based on proportions. You would have expected 34%. And you can see a similar result for the 100-year peak, and not much information for the volumes because, as you recall, stream restoration was not that effective on the volumes. So what about at the lower assessment point? That's the watershed outlet. Same kind of information here. We have the baseline volumes before, baseline peaks and volumes before we get the highway project. Then we see the increases again for the highway project in the next column. And then we see the individual effects. Stream restoration alone helps a little bit. The uplands restoration alone helps a little bit. The two of them together helps a little bit more, so that for the 2-year peak, 44% of the pre-developed, the increase because of the highway is reduced back down. And based on the screening, we applied 43%. So here the screening matched pretty closely with what we saw in the individual modeling. A similar result for the 100-year peak. And because we're now incorporating the uplands, which is a little bit more effective on the volume side, we see that we've mitigated 85% of the 2-year and 33% of the 100-year when we virtually thought we'd have no effect when we actually put it into this particular model. So we haven't gotten all the way with this scenario, so the next thing to do would be to go back and see if we can find other mitigation measures, or maybe the gap needs to be met with on-site treatment. That's another option too, because it's not either or, it's a combination. The watershed approach, you think about the entire watershed, but that doesn't mean you exclude the traditional sorts of approaches. On the co-benefits side, basically the detailed analysis might use some more detailed modeling of ecological effects. The red text, which you no doubt can't read, talks about additional phosphorus and nitrogen that goes into the reservoir and what the benefit to that might be. Talks about the value of additional recreational activities. But the process is going to be iterative, and it's going to require some patience, and it's going to require thinking outside of the box to bring in those kinds of stakeholders, which could include regulatory agencies as well. So some observations, which were illustrated, I think, in this example, are first of all that the watershed approach offers an opportunity for improving outcomes. I hear many, many times, and I've seen how ineffective on-site stormwater detention can be in very small areas, especially if it's not maintained. So if we really want the long-term effect to be positive, better solutions to stormwater management are possible on a watershed basis, where you can find long-term solutions that continue to offer the stormwater benefits. So that's one thing, but it's going to require creativity. Second is the important part about co-benefits. You're starting to bring people into the transportation process that wouldn't necessarily be in the transportation process by finding people who are interested in stream restoration, wetland restoration, and providing regional opportunities for addressing those stormwater problems. And the multiple year approach that I was talking about leads to this kind of the concept of banking, like we do with wetlands already. But think about uplands restoration banking or stream restoration banking, or these multiple year projects in a watershed where you know there's going to be some more development. Let's identify those areas in the watershed while we can, where we can do these restorations and basically bank those benefits. I've already addressed the idea that suitable locations can be a challenge. We were originally talking about needing 177 acres. When we started looking throughout the watershed and working with people familiar with the watershed, we didn't find 177. So that leads us to the need to mix and match in your solutions. And I think this is really attractive. If you get those off-site solutions, if you get those regional solutions, then you have less on the DOT plate because you have fewer site-specific facilities that you have to manage and maintain. And then finally, co-benefits is a developing science, to say the least, or a developing art, perhaps is a better way of saying it. The co-benefits change. If you think about forestation or reforestation as an example, the benefits for carbon sequestration change over time. When you first plant, they have much greater benefits in terms of carbon sequestration than later when the trees are growing much more slowly. So that's an area for future development and future research, not by this group probably, but by other groups. So the final report should be out shortly. We have a guidebook that leads people through directly these steps and how to evaluate them. There's also a spreadsheet associated with this project to help guide people who are interested in trying to think outside of the box through the process. And the information on the project's at that website, but as I said, the project deliverables are not there yet. But I'd be happy to answer any questions if we have time. So thank you for your attention. I'm not aware of any good examples of where this is, where people are getting ahead of this. I mean, I think the NCHRP project was state-driven. People were interested in starting to think about it, and it did come out of the banking idea. Can we bank some of these things if we get involved in larger mitigation projects?
Just to follow up on that, what about LID, like retrofitting existing areas that might be easier, like parking lots and other things? Would you guys look into that at all?
The LID and, retrofitting smaller areas, I think we were looking at more larger landscape things, but that can be part of the process. I mean, I think the idea of this whole framework is to think differently about how we mitigate stormwater management, not necessarily staying within the right-of-way. We always talk about how constrained that right-of-way is. So all of those things, it's really an all-of-the-above solution. Yeah.
Any other questions? Do some of these strategies, like the upland forest restoration stuff, does that require land acquisition, or how does that work out?
That's a good question. It does require land. And one of we came across a few examples. We had other case studies. There are other case studies, one in Massachusetts and one in Washington State. And we came across many stakeholder groups that had land, but didn't have money, or had an interest in acquiring land. And so the creativity and the partnerships includes finding these people that are out there. I mean, I donate money to a couple of land trusts and water trusts, and their whole purpose is to acquire land. And so if a DOT maybe can help fund acquisition of land to help meet the requirements, or provide other people who are interested in funding, but it does require land. And it's not necessarily envisioning that the DOT is going to become a big landowner in the watershed, but looking for those stakeholders. Yes. Yeah, Charlie, if we...
Even before all this, traditionally DOTs have done a lot of wetlands mitigation. So did you see any way to combine this into one big general mitigation solution?
We looked closely at how this could be expanding the whole concept of wetlands banking. And that is the model for, and I was talking about banking, and that is a model. I won't call it the model, even though I just did call it the model. It's a model. The problem with and the wetland scientists that we had on the team were the least bullish about using that model, because the wetland regulation regime is so constrained. And so it's hard to get multiple credit for both stormwater management and for wetlands creation at the same time. But I think it's worth thinking about it. And there's not that regulatory setup for uplands restoration or stream restoration or forestry, so there's a little bit more of a blank slate there.
Good. Give a hand to Roger.